The idea of this prosthetic arm originated from my interest in biomedical engineering, so I decided to grab a couple of my friends to carry out this plan that I had for the ASU project. We wanted to create a prosthetic arm that was cheap and affordable to those who couldn't afford a proper prosthetic. A typical myoelectric prosthetic costs around $20,000, with maintenance and replacements over the course of an amputee's lifetime. The cost can sum up to around $800,000. We ultimately wanted to create an affordable and easily replaceable alternative for those who couldn't afford the traditional prosthetic.
When Paul first came to me with the idea of creating a prosthetic arm, I was immediately hooked. I had never really considered biomedical engineering as a pathway for me, but I liked working on little detailed projects, and the arm had a lot of moving components that needed to fit together. Paul and I primarily dealt with the mechanical side of the arm, designing and modeling it, while Justin did the programming and the electric components. When I first started working on the prosthetic arm, I had no idea what I was doing. The software Blender that we used, which is a free 3D modeling software, has a really steep learning curve, so it took a lot of hours just fooling around, watching YouTube tutorials before I really figured out what I was doing. But once I got the hang of the program, I really came to appreciate a lot of the really neat features it included.
Later on, learning the major commands for the Blender program, I was able to manipulate a cylinder to meet the needs of fitting the right proportions of the arm that we were basing it off of, which was a picture of Justin's arm.
So with the design of our arm, we took the pre-existing guy wire model and we added a twist to it. So the guy wire model basically relies on a set of strings that run through the fingers, and when tension is applied to the strings, the fingers will contract. But the twist we added is using a MyoAware muscle sensor, which we'll discuss in a bit. But essentially, another challenge that we looked at is how to get the fingers to spring back up into their initial position after the force of tension was released. We considered using another set of strings, but ultimately we decided to have elastic cords that would run across the back of the hand, and so that once the tension on the string was released, the fingers would return to their initial upright position.
So the system that pulls the fingers back is actually really simple. We use the Arduino muscle sensor, which detects the nervous impulses beneath the skin in the muscles and transfers that over to an Arduino board, which will take the inputs from the muscle sensor. It'll compare it to a certain threshold value. Once the inputs cross over that threshold value, it'll finally turn the motor. The motor that we used to pull back the fingers is a high torque motor, because we found out that a regular motor didn't have the necessary strength to pull back the fingers all the way.
So I primarily worked on designing the finger. So my first attempt at a finger was not that great. So when I tried to print it, it was just this jumble of filament. So obviously I figured out I couldn't just print the finger at once. I had to separate the joints and print them separately. But even when I did get that design printed, it had very limited mobility. Each joint could rotate around 45 degrees, and that's not nearly enough. So I got back to work, and I encountered a few challenges with Blender. One of the problems that I have with the program is that if you mess up or make one little mistake early on in the design process, it can be really difficult to correct. You have to go back to when you made the mistake, fix it, and then start all over again. So I started saving multiple copies of what I was doing when I was working on, or before I started making any big changes. And eventually I got to the second prototype, which was much better. The finger, each joint could rotate a full 90 degrees. And the joints were held together by these rods. And so to seal the rods in place, I used a hot glue gun to melt the ends and ensure that this finger wasn't going to be falling apart.
The coding for the project wasn't that difficult, actually. I'd say the more difficult portion was the design and the circuitry. When we first started doing the project, we decided on using a Raspberry Pi. That led to some complications, such as, well, for the most part, the Raspberry Pi couldn't accept digital inputs without the requirement of certain add-ons. Those add-ons ended up costing a lot more, so we decided to forego that and use the Arduino board instead. But that wasn't without its own complications either. The first time we used an Arduino board, we tried to connect it to an external power outlet, but we ended up mixing the voltage in and ground inputs which might have caused a fire and burned one of our boards. There were some other components that also needed some soldering, which was difficult for me as a novice solderer without a proper soldering station. But in the end, I'd say the most valuable thing I received from this project was, as a programmer, I don't get much hands-on experience with circuitry and such devices, and so I'd say it was really nice for me to get my hands dirty for once, or burned in this case from soldering.
I think the prosthetic arm has a great capability to help people, considering how expensive traditional prosthetic arms are. The design that we've created will make prosthetics greatly more accessible for all kinds of people in all kinds of parts in the world. While completing this project, I really felt I grew more confident in my capabilities as an engineer. By the end, I was kind of like, hey, I really enjoy solving these types of mechanics-based problems, and this is something I could really do for a living. I also got a sense for the different steps in the design process and learned about the value of planning in advance.
I feel like there's definitely still room for improvement, but we created a product that can help people. I've enjoyed the stressful environment, the organization that I had to go through, and the whole process of creating this arm. And the idea that this project could help real-life people who are struggling to afford a prosthetic arm was a key motivation for this whole project.
So today we're going to be demonstrating the prosthetic arm in motion. Right now I have the prosthetic arm here with me. It is connected to an Arduino board, which is connected by this wire to my laptop. Now the reason I have it hooked up to my laptop is, normally you would control the prosthetic arm using this device called a MyAware sensor. MyAware sensor would be connected to my arm, so whenever I flex my arm, it would read the EMG signals and send the command to the prosthetic arm to move. Now the reason why we're not using this today is because the electrodes that we ordered are really expensive, and we only have a total of 3 of them, which is enough for one more demonstration. So we're going to save that for later, and right now we're just going to show you using the computer, using the console. Okay, so here's the arm in its open position. I'm going to send a command through the computer, upload it, and it should be compiling. Give it a second. And as you can see, the arm closes by itself. Okay, now I'm going to send one more command through the console. And when I upload it, it should open up all the fingers. And there you have it. That's the prosthetic arm in motion.